All right, let's jump right in. We are about to pull back the curtain on something your computer does every single second you're online. It's basically a magic trick, and we're going to figure out how it works. Seriously, just think about that for a second. You've got your boss's face on a video call, your favorite playlist streaming, and a huge file downloading in the background. And it's all coming through one single internet pipe. How on earth does your computer not get all of that tangled up? How does it know what goes where? Well, the answer comes down to two, let's call them unsung heroes of the internet. And I love this analogy. One's a sprinter, built for pure speed, and the other is a marathoner, built for perfect reliability. By the end of this, you'll know exactly who they are and why you absolutely need both. But before we meet our two heroes, we first have to understand the huge problem they were designed to solve. Really, it all boils down to a massive sorting and delivery challenge. Okay, so here's the core idea. Imagine your computer's IP address isn't a single house, but a giant apartment building. All of your apps, Zoom, Spotify, your web browser, or different apartments. Now, multiplexing is just all those apartments sending their mail out through the one main door. Easy enough. But the real magic, the tricky part, is demultiplexing. That's when a flood of mail comes into the building, and something has to act like a mail carrier, read the apartment number on every single letter, and make sure it gets to the right place. And that apartment number in the real world, in the internet world, we call that a port number. So every single chunk of data that hits your computer has two addresses, the IP address, which is the building, and the port number, the specific apartment. It's this simple two-part system that lets everything happen all at once. Pretty clever, right? All right, time to meet hero number one. This is the protocol that is built for just one thing, pure blazing speed. This is UDP, our sprinter. The best way to think about UDP is to think of it like a postcard. It is super fast and so simple. You just write your message, slap on an address, and drop it in the mail. There's no setup, no tracking numbers, no fuss. It's all about speed. But what's the catch? Well, just like a postcard, there's absolutely no guarantee it'll get there. And if you send a whole bunch of them, they could arrive in a totally random order. UDP basically just says, I'll give it my best shot. So you're probably thinking, why would I ever want something so unreliable? Well, you want it anytime speed is more important than perfect accuracy. Think about a live video stream or a fast-paced online game. Getting a slightly pixelated video frame right now is way better than getting a perfect one 2 seconds from now. By then, the moment is gone. It's for anything where losing a tiny packet of data here and there won't ruin the whole experience. Okay, so if UDP is our fast and loose sprinter, let's meet our second hero. This is TCP. And TCP is the complete opposite. It's our meticulous, careful, detail-oriented marathoner. For TCP, it's not about being the fastest, it's about making sure you get to the finish line with every single piece of information perfectly intact. And this just lays it out perfectly. If UDP is a postcard, TCP is like a registered letter that you have to sign for, with tracking and delivery confirmation. Yeah, it's a bit slower because there's all this extra administrative work, this overhead. It has to set up a formal connection, it numbers every packet, and it waits for a got it message for each one. But the payoff? It's huge. You get guaranteed 100% error-free delivery every single time. So how does TCP actually pull off this amazing feat of reliability? Well, it all starts with a very polite, very formal introduction. It's called the three-way handshake. Before even a single byte of your actual data, like from the website you're visiting, is sent, your computer and the server have this quick little chat. First, your computer sends a SYN packet, which is basically just saying, hello, can you hear me? I'd like to start a proper conversation. The server then replies with a SYN ACK, which means, yep, I'm here and I hear you loud and clear. Finally, your computer sends one last ACK saying, awesome, connection established. Only then, after that whole dance, does the real data start to flow. So there you have it. We've got the sprinter, UDP, and the marathoner, TCP. One is fast but a bit chaotic. The other is slower but totally reliable. And here's the brilliant part. The internet doesn't make you choose one over the other. It lets each application pick the right tool for its specific job. This chart really just says it all. It's never about which one is better. They're just built for different things. I mean, you wouldn't send a postcard to transfer your life savings, right? And you wouldn't hire a courier to deliver a registered letter just to shout hello across a field. The internet gets this. It uses UDP when speed is everything, and TCP when accuracy is everything. So, here's the bottom line. The next time you're browsing a website, downloading a file, or sending an email,
You can thank TCP, the marathoner, for making sure every last bit and byte shows up perfectly. And when you're in a video call that feels perfectly in sync or dominating in an online game, give a little nod to UDP, the sprinter, for making it all happen in real time.
And this all leaves us with a really fascinating question to think about. As we move into the future with things like the metaverse or real-time AI conversations, things that need to be both instantaneous and perfectly consistent, which hero are we going to rely on more? Are we going to need even faster sprinters, or maybe even smarter marathoners? Or just maybe will we need a whole new type of hero altogether?